Hey guys, welcome back to another episode of Math Unlocked. I'm your host, Mrs. Rhodes-Grierson. Today, we're looking at solving inequations. So, if you're here, it means that you would have watched the video already on reading equations and understanding what they represent before you come to the video on solving inequations. So if you have not watched that video yet, I'm going to ask you pause this one, go and watch the video on reading your inequations, and then you just come back and let's go. Now, I want to solve this statement here. And in order to solve it means I want to know what is the value of that unknown in the statement. So solving means we want to find the value of the unknown. I look at this statement and I can see that the unknown is my x value here. I don't know what that value is right now, but I want to know what are the values. And I say values because it's an inequation. Now, looking at it, we're going to be solving similar to how we would have solved or equations by making x the subject of the statement. So in order to know what are the values or values of value or values of x, I want x to be on one side of this sign, one side, all by itself. That's the most important thing that you need to remember when solving an equation or an inequation. You want the unknown to be on one side of the inequation or equation by itself. So I'm going to circle my variable that I want to be the subject, and I'm going to use the onion method similar to what I would have used to solve equations to say what are the things that I need to remove from this side of the equal sign in order to get this letter here by itself. Now I use the onion because what the onion does is that it allows me to see that this is my core. This is the first ring on the onion, on the core, and then the second ring is the one. Now, if I was literally peeling an onion, I would have to peel the outermost ring first. So if I'm going to remove these numbers, it means the one must be removed first. To remove means that we're doing the opposite operation. So opposite to addition would have been subtraction of 1. But because of this sign here that is stating that what is on this side is either greater than or equal to what is on the other side, it means that if I subtract a 1 from this side to maintain that balance, I'll have to subtract 1 from that side as well. Now this one is eliminated because that creates a 0 pair, because positive 1 and negative 1 gives us 0. So these pair of numbers give us 0. So we call them a 0 pair. We really want to eliminate them. That's why we do that. So what's left now on the onion is the 2x is now greater than or equal to 6. So the two sides have been reduced by 1. Now I need to get this 2 that is multiplying x to be removed so I can know what is 1 unit of x and not 2 units of x. So we're going to divide, which is the opposite of multiplication, by the 2. But because of the inequation, we have to do it to both sides to maintain its the statement to be true. So we now need to cancel this to say what now is x be greater than or equal to 6 divided by 2 is 3. So we're saying that x is itself is greater than or equal to 3. Is that true, or will that value make the original statement true? Now the original statement was 2 times the value of x plus 1 should be greater than or equal to 7. So let's check to see. If they say, if we have solved to say that x is greater than or equal to 3, then we're going to check some values of x. If x is greater than or equal to 3, then x could be 3. So let's see if that makes the statement true. 2 times 3 is 6, and 6 plus 1 is 7. So, and 7 is actually greater than or equal to. So 7 is equal to 7, so that makes the statement true. But we could also check another number greater than 3. Let's check 4. What if x was 4? 2 times 4 plus 1. 2 4s is 8, and 8 plus 1 is 9. And 9 is actually greater than 7. So that would also make the statement true, which proves that x is actually greater than or equal to 3, and that makes that statement true. So in solving an inequation, what you want to do is to make that variable the subject of the statement, just as how you'd have made the variable the subject of the statement when it was an equation. You solve by the balancing method, and you can apply the onion approach to get that variable by itself. Stay tuned for the other. Stay tuned for the other video where we explore what if we're solving an inequation and the coefficient of the variable is negative. Does that affect what we do?